Welcome to part 3 of graphing rational functions, chapter 7, section 2. You are probably tired of graphing by now, but it is what it is. It's tedious, it takes its time. I know the last video was very long. This video might be, it might not. I have some other tricks to show you. We're gonna just take it one step at a time. Hopefully you're graphing along with me. Should probably call this whole thing graph with me. I'm going to show you my notepad. You are going to open, I don't know why I keep saying notepad, notebook. You're going to open to page 368 and we are going to do number 5. And since I'm kind of tired, wow, that's blurry. Since I'm kind of tired of using black and purple, let's use blue and green. Hopefully it shows up for you, right? So this is chapter 7, section 2, part 3, more graphing, a little bit more complex. Some of it's going to be simple. I have another trick to show you. It's going to impress your pre-calculus teacher when you get there. And again, we're just going to do 3 problems. All right, and it's probably going to take time because it's going to take time. I'll try to go a little faster, and if you need to pause, rewind, you're more than welcome to. All right, what do the directions say? Graph the function, state the domain and range. Of course they say that. F of x, we're just going to write y equals x minus 1 over x plus 3. All right, T-chart, 6 points. Okay, what can't x be? X can't be -3. When I plug in -3, add 3, I get 0, does not exist. 3 numbers that are bigger, 3 numbers that are smaller. All right, let's start with -2. I got to do some math on the top and the bottom. All right, I'm going to try to stay organized here. -2 take away 1, -3, -2 plus 3, 1, so that simplifies to -3. -1 take away 1, -2, -1 plus 3, 2, that simplifies to -1. 0 take away 1, -1, 0 plus 3, 3. All right. Let's plug in -4. -4 take away 1, -5, -4 plus 3, -1, so that simplifies to +5. -5 take away 1, -6, -5 plus 3, -2. This simplifies to +3. -6 take away 1, -7. -6 plus 3, -6 plus 3 is -3. So that simplifies to 7/3, but I really don't want to use that as an improper fraction here. 3 goes into 7 2 times with 1 left over, so that's going to be 2 1/3. I know I went a little fast. I'm going to try to slim this down or streamline this. So if you need to pause, rewind, do the math on a scientific calculator, I prefer you do it in your head, go for it. All right, over to graphing. Let's see, my x's are all negative, so my y-axis can be out here. And then what? I'm going up to 5. I'm going down to -3. I'm probably gonna have to do by halves. Probably should need more space. So let's find out. Let's do the y-axis first. I don't know where to put my x-axis yet. So let's say this is 5, 4, 3, 2, 1. Okay, this will be my x-axis. And I got to keep going though. -1, shouldn't have stopped there. -2. This is why you don't draw in pen. -3. Okay, and then now I'm gonna count by halves again. So -1, -2, -3, -4, -5, -6. Let's just put a 1 out there for fun. All right, -6, comma 2 1/3. So -6 and comma 2 1/3. That's 2 1/2. So this is 2 1/3. It's just a little bit underneath this line. -5, comma 3, -4, comma 5, a little confusing. -3 is my vertical asymptote. Oops, I should keep going. X equals -3, right? We label it, dash line, label it. -2, comma, -3, -1, -1, and 0, -1/3. This is -1/2, so this is -1/3. Okay, where is my horizontal asymptote? So, I mean, you know, these are symmetrical, right? It's it's an odd function. I don't think we've talked about that yet. You're going to get to that in pre-calc. It's an odd function, so it's kind of like symmetrical diagonally. But here's our vertical asymptote. So where would that new center be that it's symmetrical around? Well, it doesn't look like it's going to be the x-axis because this is super duper far away from the x-axis, and this is really, really close. Well, when it's looked like this, let's write our coefficients in front of the x. We have a 1x minus 1. We have a 1x plus 3. All right, so you can impress your pre-calculus teachers next year. If you have a rational function, that means, you know, it's a fraction with x's in the top and the bottom, or at least x's on the bottom, and the x's have the same exponent, which they do in Algebra 2. Don't worry about it. Pre-calc gets a little different. But we have the same exponent as 1, right? So let's just circle the coefficients. 1 over 1. What does 1 over 1 simplify to? It simplifies to 1. So our horizontal asymptote is going to be y equals 1. And take a look. This is 1, 2 1/3 boxes away, and this is 1, 2 1/3 boxes away. So it's actually, that's the middle line. Oh, actually, sorry. Y equals, what did I say? 1 over 1 is 1. Okay, so there is no plus or minus back here. In fact, unlike everything before, we have an x on top, we have an x on the bottom. You need to identify the coefficients of x, write that down. You need to identify the coefficients of x, simplify the fraction, 1 over 1 simplifies to 1, and that's going to be your new horizontal asymptote, y equals 1. All right, now that we know our horizontal asymptote, we already know our vertical asymptote, we can connect the dots. No touching, no crossing. No touching, no crossing. No touching, no crossing. No touching, no crossing. What is our domain? Our domain, curly brace, x, such that x cannot equal -3. And what is our range? Our range is y, such that y cannot equal +1. Okay? So the new thing was how to identify the horizontal asymptote when it looks like this. Coefficients, simplify the fraction, there you go. All right, move on to number 6. Let's see if we can do it together. Y equals, well, f of x equals, but we write y, 2x plus 1 over 4x take away 2. Oh, sorry. There we go. Okay. All right, let's start with our t-chart. Now, what can't x be? What do we plug in here so that this whole denominator is going to be 0? Well, I'd like you to think about it, you know, what happens when we do this? Let's solve for x, right? 2 over 4, now that simplifies to 1/2. So 1, 2, 3. Oh yeah, that's fine. 1/2, right? If I plug in 1/2, 4 times 1/2 is 2. 2 take away 2 is 0. But let's think back to actually factoring to solve for quadratics in chapter 3. Let's say we had a factor and I said, okay, what is the solution to this quadratic? And this is in parentheses. All right, so picture parentheses around the denominator. Well, the trick was that I showed you, you could say top, bottom, change the sign. 2 over 4, make it positive. Well, 2 over 4, make it positive, that's 1/2. So you can do it that way too. You can spend the time doing it the Algebra 1 way, or you can kind of intuit it better, think back to chapter 3, apply those skills there. All right, but you know what? Here's a fraction, you're freaking out. Oh my God, everything's gonna be fraction. No, maybe it won't be. The rules still apply. We can still pick 3 numbers that are bigger than x, 3 numbers that are bigger than 1/2, 3 numbers that are smaller than 1/2. Well, all right, what's a number bigger than 1/2? 1, 2, 3. What's a number smaller than a half? 0. -1, -2. All right, so it's not that bad. Don't make your life more complicated. Graphing rational functions is tedious. It's complex as it is. You don't need to make it more tedious and more complex. Okay, but let's be careful. We are going to plug in 1. 2 times 1 is 2. Yeah, 2 times 1 is 2. 2 plus 1 is 3. 4 times 1 is 4. 4 minus 2 is 2. So 3 over 2 is 1.5. 2 times 2 is 4. 4 plus 1 is 5. 4 times 2 is 8. 8 take away 2 is 6. So 5 over 6. 2 times 3 is 6. 6 plus 1 is 7. 4 times 3 is 12. 12 take away 2 is 10. So we do have 7 10. All right, we do have fractions. Whatever, we have fractions. We can graph them. 0. Well, 0 plus 1 is 1. 0 take away 2 is -2, so -1/2. Let's plug in -1 carefully. -2 plus 1 is -1. -4 take away 2 is -6. So we have 1/6. -4 plus 1 is -3. -8 take away 2 is -10, so that becomes +3/10. Check my work, please. Make sure it's correct. Check your work. All right. And I'm going to keep rolling because you can check my work and let me know tomorrow. But, you know, I'll find out if I graph it and it looks really weird, although it's probably going to look kind of confusing as it is. All right, so tiny little numbers, biggest number is 1.5, smallest number is -1/2. So I better zoom in on my y-axis. My x-axis, however, still just goes from -2 to 3. So let's make my x-axis somewhere in the middle. Let's make this -2, -1. Here's my y-axis. Oh, I'm not getting very straight here. 1, 2, 3. Okay, so what is next? All right, so I got 3 tenths. I'm not going to be as specific as tenths, but maybe I will count by, I'm going to count by eighths maybe. We only have to go up to 1. How many boxes do I have? 1, 2, 3, 4, 5, 6, 7, 8. I'll have to get to 1.5. So you know what? Let's actually count by thirds. 1/3, 2/3, 1. 1 1/3, 1 2/3, 2. I don't really know why I picked that. It works. All right. -2, 3/10. So -2. Now, if this is a third, that's 0.3 repeating. So 3/10 is just 0.3. That's kind of just right underneath there. -1, 1/6. Well, wait. If this is 1/3, 1/6 would be then halfway between 0 and a third. And then 0, -1/2 is halfway between -1/3 and -2/3. When x equals 1/2, I have my vertical asymptote. All right, that makes me feel a little bit more comfortable. 1, 1.5. Well, that's halfway between a third and 2/3. 2, 5/6. All right, well, wait. This is a third. This is 2/3. 2/3 is the same as 4/6. So 5/6 is right here between 2/3 and 1. And then finally, 7/10. Well, this is 2/3, which is 0.6 repeating. So 7/10 is right above it at 0.7. Okay, now what is my horizontal asymptote? Let's go to the coefficients of x's. It's 2/4. What does 2/4 simplify to? It simplifies to 1/2. So that's going to be right here. I know you might be scared of fractions. You might want to pause and rewind just so you can get comfortable with how I did this. You can do it differently if you want to count by fourths or something, you can, but we had to get in kind of to the tenths and see a difference. All right, so we know y is a half is my horizontal asymptote because 2 over 4 simplifies to a half. So I can graph. Gets a little flat really quickly. No touching, no crossing. No touching. No crossing. Not perfect. I'd want it a little bit more vertical like that. There we go. What's our domain? All the x's such that x does not equal 1/2. What's our range? All the y's such that y does not equal 1/2. Okay. All right. Fractions made me slow down. Hopefully this works out. Let me know if I did any mistakes. But actually it looks very symmetrical. So I would imagine these are the correct answers. And finally, let's do number 7. I'd like for you to try to do it on your own, but obviously I can be in the background doing it with you. F of x equals negative 3x plus 2 over negative x take away 1. Okay. Some of you have to think really hard about negatives. What number do I plug in here that will get me a 0 in the denominator? Well, let's see. I could do negative x take away 1 equals 0, add 1, divide by negative 1. I could also do top 1, bottom over negative 1, so that's negative 1. Change the sign, that's positive 1. So 1 is my center. Also, if you solve this for 0, sorry, if you solve this for x, you get negative x equals positive 1, and then you divide by that, you get negative, wow, I just did that wrong. So wait a second. Top 1, bottom negative 1, change the sign. Let's if I plug in 1, negative 1, take away 1. Yeah, that's negative 2, that's wrong. So it's gotta be negative 1. I'm glad I did the algebra one way. So because if I plug in negative 1, negative times a negative is a positive, that's positive 1, take away 1 is 0. And we can't have 0. There you go. Sometimes the shortcuts don't work. It's that negative that screwed up my trick from chapter 3. Okay, 3 numbers that are bigger. 0, 1, 2. 3 numbers that are smaller. Okay, nice and slow with the math. Let's plug in 0. That's the easy one. 0 plus 2 is 2. 0 take away 1 is negative 1, so that's negative 2. Negative 3 plus 2 is negative 1. Negative 1 take away 1 is negative 2. Negative 6 plus 2 is negative 4. Negative 2 take away 1 is negative 3. 6, we're plugging in a negative, right? 6 plus 2 is 8. 2 take away 1 is 1. Ooh, that's a jump. 9 plus 2 is 11. 3 take away 1 is 2. 2 goes into 11 5 times with 1 left over. 12 plus 2 is 14. 4 take away 1 is 3. 3 goes into 14 4 times with 2 left over. Okay, now I got something to graph. Ooh, we're going up to 8. And we are going down to negative 2. I'm going to count by halves, I guess. And then my y-axis is going to be pretty much in the middle. So let's say 8's up here. 7, 6, 5, 4, 3, 2, 1. Here's my x-axis. Negative 1, negative 2. Ooh, gotta zoom out here for you. 1, 2, negative 1, negative 2, negative 3, oopsies, negative 4. Sorry about that. 1, negative 2. Okay. So negative 4, 4, and then 2/3. Here's 4.5, so 4 2/3 is just above it. Negative 3 is at 5. Oh, I'm sorry, I'm off 1. Oh, my eyesight. I apologize, children. -4 is on this line. -3 is on this line at 5.5. -2 is all the way up at 8. -1 is my vertical asymptote, so dashed line, don't forget to label it. X equals -1. 0, -2. 1 and is at a half, and then 2, oh, I never even saw 3 goes into 4 once and a third. 2 is at 1, and then a third is a little bit under 1.5. Now, where is my horizontal asymptote? Let's go to the coefficients. And I'm gonna, this is messy. My coefficients, -3 over -1. What does that simplify to? +3. Y equals 3 is my horizontal asymptote. It looks pretty symmetrical. Keep in mind that does not exist, that little X thing that I X'd out there. And it's a pretty big graph. It's going to be pretty far away, but you still need to show me that you know that it doesn't cross, doesn't touch, doesn't loop back on itself. So do that as neat as you can. Okay, nice big swooshes. And there you go. All right, so this was graphing with X's on the top and the bottom. There was no plus or minus out back to easily tell us what our horizontal asymptote is. So we had to go to the coefficients of the X and simplify. Did the same thing to start the t-chart. What can't we have in the denominator? Sometimes it's tricky and screws your teacher up too. So be careful. And then 3 integers above, 3 integers below. Go ahead to the graph and make a nice graph. Oh, domain and range. What's our domain? X such that X doesn't equal -1. What's our range? The Y's, such that Y doesn't equal, what did we figure out? 3. Okay, there are more videos to come. It's all graphing. It takes time. If it takes time for me, it takes time for you. Be as neat as possible.